Next, let's talk a little bit about vacuum chucking systems. As we talked about in the PowerPoint presentation, there are two primary kinds of vacuum chucking systems used by woodturners. The first one is the one shown here. This is an oilless electric vacuum pump system that operates obviously on the basis of having this small electric vacuum pump connected to your lathe, and it's connected by means of a tube that runs to whatever connection system you're using. It could be for, like this on my Powermatic, it's a simple little connector that just plugs into the hand wheel, which is very convenient if you don't have that available to you because it's only made for a few kinds of lathes. Then you can use the threaded rod that's hanging in the back over there. That's a threaded rod that goes through here and out the end of the spindle with a little knurled nut that has an O-ring on it that seals it for using it as for vacuum chucking. So either of those connection methods, you use that to connect to your lathe to create the vacuum needed for a vacuum chuck. The vacuum system is turned on at the vacuum pump, and you'll see it makes a little bit of noise, so my apologies for the noise. And you'll see it doesn't really draw much of a vacuum. In the gauge, it runs from 0 up to minus 30 inches of mercury, which is maximum atmospheric pressure. If you put your finger over the hole in the vacuum chuck, you'll see the gauge goes up to almost 27, which is about the maximum these kinds of systems will draw. And take your finger off the gauge and it goes right back down again. So it's drawing a good vacuum here at my house, where we're only a few feet above sea level, so it should be drawing almost at full maximum 27 inches, and it does. All right, now let's take a look at the other kind of system that is typically used by woodturners. All right, this is the hold-fast vacuum generator system. This operates on the Venturi principle and requires a compressor capable of drawing at least 2.5 cubic feet per minute of air. This system also will pull a vacuum of about 27 inches, so it works just as well as the electric pump, assuming you have a generator. Not everyone has a generator, or at least a compressor capable of drawing 2.5 cubic feet per minute. So you may not have one at all, or may not have one with that capacity. But if you do, this is certainly a very decent option to use. If you set your compressor, as you can see, has a maximum PSI of 125. You don't want to set your compressor above that. But if you do set your compressor at 125 PSI, it will draw up to the full 27 inches of mercury. So it's an excellent alternative to an oilless vacuum pump, because the oilless vacuum pumps are hard to find. Robust sells one now, but they are difficult to find at any kind of a reasonable price. This hold-fast system attaches to the lathe, again, using a tube. It goes up to the same kind of threaded rod that we were talking about on the Powermatic. And again, the rod goes through here, connects to your spindle, and you put it on your vacuum chuck, and away you go. You have a nice vacuum system for your lathe without the need for an oilless vacuum pump. Now, the next issue that you have to confront when using a vacuum chuck is, how do you get the bowl correctly centered on that chuck? You can try to do it by hand. Not as easy as you might think. Takes a lot of monkeying around with it to get it spinning reasonably true. The easiest way to do it without having to monkey around with it is to reverse mount your bowl while it's still in the chuck, to reverse mount it on your tailstock using one of these kinds of reverse chucking adapters. This is the static kind of chucking adapter. It does not spin at all. It's stationary. This kind is simply your live center with an adapter that adapts the thread from 3/4 by 10 to 1 1/4 by 8 on my lathe. I don't use this to mount bowls on a vacuum chuck, only because it really doesn't provide the kind of stability that one wants. There's a little play in it. So it's difficult to get a perfectly true mount or even a reasonably true mount. You have to monkey with that a little bit. It's much easier using a static reverse chucking adapter like this. That simply goes in the tailstock like this. You'll see it mounted on my chuck here, and that gives you a much better chance of getting a true running mount the first time. All right, now how you mount a bowl onto a vacuum chuck is pretty straightforward. First, you simply turn on the generator, or the vacuum pump rather. And once you have the vacuum pump operating, then you simply wind bring the tailstock in and wind it against the vacuum chuck until you'll hear it grab, and then you simply loosen the chuck and then draw the tailstock away from the piece, and you'll see that it is now operating at, let's say, about 20, almost 23 inches of mercury, which is more than sufficient for holding it securely. And you'll also see that it spins quite true on here. Now, the difficulty that you have with some types of wood, this is a very porous wood. You can feel it on the rim. I have tried mounting this on a vacuum plate just to see what it would do, and the walls up here are so thin that it draws way too much air through. It'll literally reduce the draw to about 5 inches of mercury. So this would not be a candidate for using a vacuum plate with, but it works fine since the vacuum chuck here, as you can see, is limited to the base of the bowl where it's thicker, not drawing through the rim where it's much thinner and much more porous. So you have to adjust your chucking method to the particular wood that you have. This one works just fine with this particular kind of vacuum chuck, which is one of the hold-fast chucks. All right, then the next thing we want to take a look at is using a vacuum plate. In the prior example, we used a vacuum chuck, and in the PowerPoint presentation, we showed all the different kinds of vacuum chucks that are available, the different sizes and shapes of them. So you pick whichever one works best with your particular piece. It may be if you're doing a bowl that has a nice even rim, you want to use a vacuum plate. It provides a very stable hold. This is a very basic, very basic vacuum plate made out of MDF. I would not use plywood. Plywood will simply not stay perfectly flat over time. I've tried to make them using Baltic birch. It does not stay stable over the years. This vacuum plate I've had for quite a few years, and it works just fine. Stayed perfectly stable. I simply mount a faceplate on it and leave it permanently mounted that way. And you put, this is shelf liner from Lowe's. And after you glue the shelf liner on and mount this on the lathe, then you drill your center hole to allow the vacuum to come through. It doesn't have to be large, there's only a 3/8 inch hole. And then for ease of mounting pieces, if you don't happen to use the reverse chucking method, I simply draw lines, different color lines, so it's easy to distinguish where your piece is on the lathe. I draw different color lines every 1/2 inch on the face of the vacuum plate. Now let's mount a bowl by hand, and I'll try to do it as best I can, holding both the phone and the bowl. But I'll show you how well a vacuum plate holds a bowl on the lathe. Let's turn the vacuum on. All right, and let's simply mount a bowl right there, and you'll see how well that holds, and it is drawing 25 inches of mercury. So you'll see the vacuum plate provides a very stable hold. I'm not sure I have it mounted. Yeah, it's not mounted exactly true, but but you play around with that a little bit. I don't have a method to chuck it on the back here. You just play around with it a little bit. Simply release the vacuum, turn the vacuum pump off, and just change the position a little bit until you get it running true, and then you're good to turn the bottom, assuming there was a tenon on here that you wanted to remove. All right, one other item to talk about is that while this piece that's on here now is a very solid piece that there's no risk of the vacuum imploding the sides of it, you may well have a piece that is got very thin walls on it that you don't want to subject to a very high vacuum, because the vacuum can literally implode a bowl if the walls are simply too thin. So that's one of the advantages of having this little bleed valve on the vacuum pump, because by turning that valve a little bit, I can reduce the level of the vacuum that's holding the piece in place. As you'll see, it's going down as I turn it, or as I close that valve, then it goes back up to 25. So you can adjust very easily the amount of vacuum that you're subjecting the piece to in case you happen to have a fragile piece. Works really well to allow you to adjust it to whatever piece you happen to have. And just one final thing, let me show you what I was talking about before, about how a particular piece, while it works great with one kind of vacuum truck, won't work well with another. Let me put this bowl on the vacuum plate. It was fine with the other type of vacuum truck, but you'll see, because it's drawing through the thin walls, it's less than 5 inches of mercury using this kind of mounting method. So you have to, again, adjust your vacuum chucking method to your particular piece to make sure it's safe. Most turners tend to want it to be, I think, typically 15 inches of mercury or more. I've seen people turn with a little less. I'm not very comfortable doing that. I want to see it at least 15. And at 15, it is really hard to move. I'll be honest, this is really hard to move even at 5. It's particularly difficult to move, although putting the pressure on it while it's moving does put a lot of stress on it. So I wouldn't chance it at less than 5 inches of mercury, obviously. So anyway, that's just a general guideline for using vacuum systems.